Welcome everyone. In this video, I'm going to talk about the basics of graph. So let's start off with the definition. In very plain English words, graph is nothing but a combination of vertices and edges. So the next question that will arise in your mind is what are vertices and what are edges? To describe that, I'll be using this particular example. This is an example of a graph. So the entities or objects found in a particular graph are called the vertices. So A, B, C, D, E, F, G, H, and I are the vertices of a graph. And the vertices are connected with one another using links or straight lines. So these links or straight lines are called the edges. So this is an edge, this is an edge, this is an edge, and it goes on and on. Now let's look into the formal definition of a graph. So a graph is a pair of V and E. So it's an ordered pair of V and E. Now the next question is what is V and what is E? So capital V represents a finite set. In mathematics, you have already learned what is a set. Set basically represents a group. So V refers to a group, and that group will contain items in it, right? Items of what? Items of vertices. So the V set will contain all the vertices in the graph, and the E set will contain all the edges in the particular graph. So for this graph, the capital V will be a set, right? So V is equal to a set of items. Set of what items? Set of all the vertices in this graph. So A, B, C, D, E, F, G, H, and I will be part of the V set. And since it's a set representation, we are using the second bracket. Another important thing is n and m. What is n? N is the cardinality of V. Cardinality basically represents the number of items in the set V. So the set V contains all the vertices in a graph. So the cardinality of V will be equal to the number of vertices in the graph. Hence, n is equal to the number of vertices in the graph, and m is equal to the number of edges in the graph. So let's look at here. You can see that in this graph there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 vertices, so n is equal to 9, and if you count there will be a total of 15 edges. As a result, the value of m is equal to 15. Now let us look at this particular example. This graph contains 4 vertices and 5 edges. You can see that the vertices are A, B, C, and D. So let's list them here: A, B, C, and sorry, C and B. And you can see that all the edges in this particular graph are directed. As a result, this graph is called a directed graph. The next thing that we need to do is list the edges. The rule of representing an edge is in the UV format, where U and V are the vertices between which the edge is present. So this is an edge, right? This edge is present between vertex A and vertex B. So in the UV format, we can write it as A comma B. However, we need to keep one thing in mind, that is this edge is directed. As a result, A is the source vertex and B is the destination vertex. So while representing the edge, the direction also matters and the order matters. So the first one, the first vertex that we are showing, A, this is the source, and B, this is the destination. And in order to emphasize that this is an ordered pair, we have to enclose them within the first bracket. Okay, so AB basically represents that there's an edge from A to B. Please remember one thing: if we had enclosed uh, B comma A inside the first bracket, that would have represented that the edge is from B to A. So ordering matters here. The first one is the source and the second one is the destination. And to represent that this is an ordered pair, we enclose them within first bracket. The next edge is from A to C. So let's write it here. Next vertex is B to C. Then there's a vertex from B to D. The last one is from C to D. So we are done listing the edges and listing the vertices as well. Now the question is, how do we represent V and how do we represent E? So as we have learned earlier that V is a set, so we need to give the set notation of the second bracket, and V is a set of all the vertices in the graph. So V is a set of all the vertices, hence we put these items inside the V set. And also the E set contains all the vertices, all the edges of a particular graph. So we need to give the second bracket first and then list all the edges in this graph. So these are the edges. Let's paste it. So we are done. So V is ABCD and E is all the edges that we have listed out here: AB, AC, BC, BD, and CD. Since direction matters, so the first one is the source and the second one is the destination. Now let us look into another example. This is another example you can see on your screen. So in this example, you can see a graph that contains four vertices, A, B, C, and D, and I have listed the vertices under this column A, B, C, D, and there are four edges. All the edges in this graph are undirected. There is no direction associated with any edge. As a result, this graph is called an undirected graph. The next point is, how do we list the edge? In the same UV format is the answer. For this particular edge, you can simply write A, comma B. However, this time around, this edge is undirected. As a result, the ordering is insignificant here. You could have written B, comma A. That would have represented the same thing as well, because there is no specific source or specific destination for an undirected edge. Then there's an edge between AC or CA, whatever you want to call it. There's an edge between CD or DC, and there's an edge between DB or BD. So these are all the edges and these are all the vertices you can see here. Now let's look into the definition. You can see that graph G can be directed if E consists of ordered pairs. So if the edges are of ordered pairs, then we can call it directed graph, and if they're unordered, then we can call it undirected graph. So this is a directed graph and this is an undirected graph. Now we can also assign weights to specific edges. If we assign weights to specific edges, then that graph is called a weighted graph. We can assign weight function to the edges. WGE is a weight of an edge E that belongs to the set E. The graph which has such function assigned is called a weighted graph. Next, let's see what is a degree of a vertex. So degree of a vertex in an undirected graph basically represents the edges that are incident to a certain vertex. For a directed graph, this is divided into two parts. One is in degree and another one is out degree. In degree basically represents the incoming edges to a particular vertex, and out degree represents the number of outgoing edges from a certain vertex. So let's see this example. You can see that this is a directed graph or a digraph. So for A, you can see that there are two edges that are going out. So the out degree will be 2 and the in degree will be 0. Out degree 2, in degree 0. Then for B, there are 2 in degrees and 2 out degrees. For C, there are 0 out degrees but 2 in degrees. For D, there are 2 in degrees, 2 out degrees. E, there are 2 in degrees, 3 out degrees. You can solve the rest yourself. Now for an undirected graph, there is only degree. There is no in degree or out degree. So let's see. For A, the number of incident edges are 2. So A's degree will be 2. B's degree will be 4. C's degree will be 2. D will be 4 and E will be 5.